Welcome to Clean Energy Explained, where we break down the future of power. If you love learning about solar, wind, and renewable energy, hit that subscribe button. Now let's talk about wind turbines across the world. You may have seen tall, white structures standing gracefully in fields or off the coastlines. These are wind turbines, modern marvels engineered to capture the wind's energy. With elegant blades reaching skyward, they transform the invisible force of the wind into a valuable resource: electricity. For centuries, humans have harnessed wind power, using it to sail ships and grind grain. Wind turbines represent a significant leap forward, allowing us to generate clean and sustainable energy on a much larger scale. As the world seeks cleaner energy alternatives, wind power has emerged as a key player. Unlike fossil fuels, wind is a renewable resource constantly replenished by natural processes. Wind turbines provide a way to tap into this abundant source of energy, reducing our reliance on polluting and finite resources. In the following sections, we'll delve deeper into the fascinating world of wind energy, exploring how these incredible machines function and the impact they have on our planet. Wind, in its simplest form, is air in motion. It's created by the uneven heating of the Earth's surface by the sun. When one area is heated more than another, the warmer air rises, creating an area of low pressure. Cooler, denser air then rushes in to fill the void, and this movement of air is what we experience as wind. The strength of the wind is determined by the temperature difference between these areas. Larger temperature differences create stronger winds. This is why coastal areas often experience strong winds. The land heats up and cools down faster than water, leading to significant temperature variations. Wind energy is simply the kinetic energy possessed by moving air. For centuries, humans have harnessed this energy using simple technologies like windmills to perform mechanical tasks. Modern wind turbines take this principle much further, converting wind's kinetic energy into electrical energy that powers our homes and industries. Wind turbines may seem complex, but the principle behind their operation is surprisingly simple. As the wind blows, it pushes against the blades of the turbine, causing them to rotate. This rotation spins a shaft connected to a generator located inside the nacelle, the housing at the top of the turbine tower. The generator is the heart of the operation. Inside, powerful magnets spin within coils of wire. This movement induces an electrical current, effectively transforming mechanical energy into electrical energy. The electricity generated is then transmitted through cables down the tower and into the power grid, where it's distributed to homes and businesses. The speed at which the blades rotate depends on the wind speed. Most turbines are also equipped with a control system that adjusts the blade angle to optimize energy capture in varying wind conditions. In strong winds, the blades can be pitched to reduce rotation speed, preventing damage to the turbine. While the basic principle of wind energy conversion remains the same, wind turbines come in various shapes and sizes. The two most common types are horizontal axis wind turbines, or HAWTs, and vertical axis wind turbines, or VAWTs. HAWTs are the most common type you'll see dotting landscapes and seascapes. Their blades are positioned on a horizontal rotor atop a tall tower, facing directly into the wind. This design allows them to efficiently capture wind energy, especially at higher altitudes where winds are stronger and more consistent. VOTs, as their name suggests, have blades that rotate around a vertical axis. This design offers some advantages, such as the ability to capture wind from any direction without needing to adjust their orientation. However, VOTs are generally less efficient than HAWTs, especially in capturing wind energy at higher altitudes. The choice between HAWTs and VOTs depends on factors like the wind resource, available space, and specific application. HAWTs remain the dominant technology for large-scale wind energy generation, while VOTs find niche applications in urban environments or areas with turbulent wind patterns. Size matters. The power of scale in wind energy. Wind turbines come in a range of sizes, from small turbines designed for residential use to towering giants that dwarf nearby structures. The size of a turbine directly relates to its power output. Larger turbines, with their longer blades and higher reach, can capture significantly more wind energy. A small residential turbine might have a capacity of a few kilowatts, enough to power a single home. In contrast, utility-scale turbines can generate several megawatts of power each, enough to supply electricity to hundreds or even thousands of homes. The largest wind turbines in operation today can have a capacity of over 10 megawatts, highlighting the incredible scale of modern wind power technology. As technology advances, we can expect to see even larger and more powerful turbines being developed. These advancements will allow us to generate more clean energy from the same wind resource, further reducing our reliance on fossil fuels. A breath of fresh air. Advantages of wind power. Wind power offers numerous advantages as a source of electricity generation. First and foremost, it's a clean and renewable energy source. Unlike fossil fuels, wind turbines don't produce harmful greenhouse gases or other pollutants during operation. This makes wind energy a crucial tool in combating climate change and improving air quality. Wind is also a widely available resource. While some regions are naturally windier than others, wind potential exists across the globe, both on land and offshore. This makes wind energy a viable option for many countries seeking to diversify their energy mix and reduce reliance on imported fuels. Furthermore, wind power has a relatively small land footprint compared to other energy sources. Modern wind turbines are designed to maximize energy capture while minimizing their impact on the surrounding environment. Farmers and ranchers can even lease their land for wind energy development, providing an additional source of income without sacrificing valuable agricultural land. Facing the wind. Challenges in harnessing nature's energy. Despite its numerous advantages, wind energy also faces certain challenges. One of the most significant is the intermittent nature of wind. Wind speeds can fluctuate, and there are times when the wind may not blow at all. This intermittency requires backup power sources or energy storage solutions to ensure a reliable electricity supply. Another challenge is the visual impact of wind turbines. Some people find large wind farms aesthetically unappealing, especially in scenic areas. Careful siting and design considerations are essential to minimize the visual impact and address community concerns. Additionally, wind turbines can pose risks to wildlife, particularly birds and bats. Bird and bat mortality from collisions with turbine blades is a concern that requires ongoing research and mitigation strategies, such as careful siting to avoid migratory pathways and technological advancements to deter wildlife. Winds of change. The future of wind power technology. The field of wind energy is constantly evolving, with new technologies and innovations emerging to address existing challenges and unlock even greater potential. Researchers are exploring advanced blade designs, improved turbine efficiency, and innovative energy storage solutions to enhance the reliability and cost-effectiveness of wind power. Offshore wind energy in particular holds immense promise. Winds are generally stronger and more consistent offshore, leading to higher energy yields. Floating wind turbine platforms are being developed to tap into wind resources in deeper waters, further expanding the potential of offshore wind. As we look to the future, wind energy is poised to play an increasingly important role in the global energy landscape. By harnessing the power of the wind, we can transition away from fossil fuels, reduce our environmental impact, and create a cleaner and more sustainable energy future for generations to come. If you enjoyed this breakdown of how wind turbines work, let us know in the comments. And if you want more clean energy breakdowns, hit that subscribe button and join us in powering the future.